In this video, we will practice using the product rule and the quotient rule to take the derivative, also known as differentiating. If you appreciate the content, please give it a like. In previous videos, I have taught you 4 of the 6 derivative rules, and now I'm going to teach you the remaining 2. But first, let's review. The derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. We have also learned that the derivative of tangent x is secant squared x, while the derivative of cotangent x is negative cosecant squared x. We have noticed the pattern that whenever you take the derivative of one of these cofunctions, the rule has a negative in the front of it. So now it's time to learn the 2 new ones. The derivative of secant x is secant x tangent x. Based on that, you can probably guess that the derivative of cosecant x will be negative cosecant x cotangent x. So now we know all 6 trig derivative rules. Memorize them immediately. In general, when you take the derivative of an expression, you take the derivative term by term. So we will begin by taking the derivative of the first term, 5 times secant x. When you take the derivative of something that has a constant in the front, you just bring the constant down unchanged, and you multiply by the derivative of whatever comes next. The derivative of secant x is secant x tangent x. That's what we just learned. So now we're moving on to the next term. But, we are running into a product right here. So we are going to need to do the product rule. We have a function times another function. So I want you to look at this as this yellow function times the blue function. So the way the product rule works is you sort of go through this product twice. The first time through, you take the derivative of the first factor, the first function, and we know the derivative of sine is cosine. The first time through, you leave the second factor alone. Okay, and you put a plus in front of all of this. And then you run through it again. The second time through, you leave the first factor alone, and you multiply by the derivative of the second factor. The derivative of cosine x is negative sine x. Now, here's what I don't want you to do. When you are multiplying by something negative, don't put negative sine x like this. Or don't put it like this. Is all correct, but I'm encouraging you not to do this. The reason why is students often will accidentally forget the multiplication sign, or they'll leave off the parentheses, and suddenly what should become multiplication is now subtraction. And that's wrong, and it just throws off the entire problem. So when you are multiplying by something that's negative, I want you to take that negative and put it in the front of the term. So in this case, that minus is going to change this plus into a minus. So trust me, always do this, and it will help you avoid common mistakes. So really, for a free response question, this is a valid answer. This is also a valid answer, and you are more likely to see something like this as an option on a multiple choice question. But there's another form that you also might see on a multiple choice question. Back in pre-calculus, we learned that this is one of our double angle identities. The cosine of 2x had 3 forms that we learned, but one of them was cosine squared x minus sine squared x. So be prepared to identify this as the answer on a multiple choice question. Let me go back to this part right here. A common mistake when students see something times something is they want to just take the derivative of the first factor and then multiply that by the derivative of the second factor. So they want to take the derivative of this part and just write cosine x times negative sine x. This is completely wrong. I spend the whole year trying to get kids to stop doing this. And, in May, they're still doing this. So please start to get it through your head right now that when you see two x's side by side, two functions being multiplied together, both having x's in them, you have no choice but to use this product rule where you go through it twice and taking turns with the derivative. For number 2, we have a function divided by another function. We have an x in the numerator and an x in the denominator. So we are going to need the quotient rule. However, I would rewrite this a little bit before applying the quotient rule because the square root of 5x is a function inside of a function, and we haven't learned how to deal with that yet. That's going to be something called the chain rule, which we will learn in a video coming up soon. But for now, I would rewrite this as the derivative of tangent x over, I'm just going to split these apart. The square root of 5x is the same thing as the square root of 5 times the square root of x. And I'm not really going to write this either. You saw it, but the square root of x, is the same thing as x to the 1/2 power. So this is the rewrite that I recommend. We have not taken the derivative yet, so the d dx should still be here in your work. If you take out the d dx prematurely, like this is incorrect. If I have the derivative and here I say that's equal to this, even if my final answer is correct, this step is actually wrong. So you're going to lose a point for that. So do not take the d dx away until after you have taken the derivative. It's time to do the quotient rule, but there's a poem that helps you remember the quotient rule. It goes low d high, less high d low. Draw the line and down below, the bottom squared will go. Every time I say d, I mean take the derivative of. So d high means the derivative of the numerator. D low means the derivative of the denominator. So I'm just going to say it one more time to help it stick in your head. Low d high, less high d low. Draw the line and down below, the bottom squared will go. So first it was low d high. Low means the denominator. And d high means the derivative of the numerator. The derivative of tangent is secant squared x. That's a memorized rule. So it's low d high, less means subtraction. And then it's high d low. High is the numerator. And d low is the derivative of the denominator. I do not need the product rule down here because the factor in the front is just a constant. So when we do d low, the constant, you just bring down the constant unchanged. So I'm just going to put the square root of 5. And then you move on and take the derivative of the next factor. Using the power rule, you move the 1/2 to the front. And you reduce the exponent by 1. 1/2 minus 1 is negative 1/2. And that's it. So we have low d high less high d low. Draw the line and down below, the bottom squared will go. I'm going to square each of these. When you square radical 5, you get 5. And when you square x to the 1/2 power, just real quick, x to the 1/2 power squared, when you raise a power to a power, you multiply. And 1/2 times 2 is 1, so that's just going to be x. Or, if you look back at the original denominator, squaring this takes the radical away, and you just have 5x. Before I move on, let me mention a small but important detail. Once you take the derivative, you do not write the d dx anymore. A common mistake, I will see students write this d dx, and then they'll say d dx equals this. This is improper notation. This is not valid. This does not make sense. Do not ever write d dx by itself and then set that equal to something. That would be like saying the square root of 9 and then writing the square root with nothing in it is equal to 3. This does not make sense, and neither does this. You don't need to write anything in the front, but if you were to write something, it would be the entire original problem, not just the d dx, but the derivative of tangent x over the square root of 5x. Cosecant squared is really cosecant x, that whole thing squared. Looking at it this way, we are looking at a function that's inside of another function. This would require the chain rule to take the derivative directly, and we have not learned the chain rule yet. So instead, we are going to rewrite this as a product. So we can think of this as the derivative of cosecant x times cosecant x. Thinking of this as a product, we're going to need to do the product rule. So this is the first factor, is this yellow one, and then the second factor is the blue version. When you apply the product rule, you go through twice, taking turns with the derivative. The derivative of cosecant x is negative cosecant x cotangent x. So I've taken the derivative of the first factor. The first time through, you leave the second factor alone. So I'm going to multiply by cosecant x. And then you put a plus. And then you go through it again. The second time through, you leave the first factor alone, which is cosecant x, and you multiply by the derivative of the second factor. Well, that derivative, again, is going to be this negative cosecant x cotangent x. Do not do this and put negative cosecant x cotangent x. Students often forget to put the little multiplication sign, and suddenly it becomes subtraction, and it's wrong. Instead, I want you to take this minus sign and put it in front of its term. That is going to change this plus into a minus. If this was a free response question on a test, I would leave the answer just like this if I were you. This is a full credit answer, and why risk making a mistake with the simplification process? But we need to get ready for multiple choice questions, and this does simplify quite a bit. So first of all, we see that each of these have cosecant x times another cosecant x. So of course that's going to be negative cosecant squared x cotangent x. And this is the same thing. So minus cosecant squared x cotangent x. Because both of these terms are identical, we can combine these into a single term. You know how x plus x is 2x. Similarly, these two terms combine into negative 2 cosecant squared x cotangent x. Number 4, g of x is a product, so we are going to use the product rule. We have the yellow factor times the blue factor. So we're going to go through twice, taking turns with the derivative. The derivative of the yellow function, we're going to do term by term. The derivative of x squared is 2x. The derivative of 3 is 0, so that's it for the yellow factor. The first time through, you leave the blue factor alone. So I'm going to bring down my x squared minus 4x unchanged. Then I put a plus. The second time through, we leave the first factor alone. So we bring down the x squared plus 3. But then we multiply by the derivative of the second factor. Term by term, the derivative of x squared is 2x. And then we have the minus 4. You just bring down the constant. And the derivative of x is 1. So that's it. And I would just leave the answer like this. We are going to need the quotient rule for number 5. We see x's in the numerator and the denominator. Sometimes we can avoid using the quotient rule. when we have a function in the form a plus b over c. We have learned that this can be rewritten as a over c plus b over c. I call it the a plus b over c rule. But guess what? There is no c over a plus b rule. So we will simply have to do the quotient rule. Caution! Resist the temptation to cancel out one of these x's. You cannot cancel out factors that are connected by addition or subtraction. The quotient rule goes low d high less high d low. Draw the line and down below, the bottom squared will go. Let's go ahead and do that bottom squared part, because I just said it, it's fresh in our minds. The bottom squared will go. So now we need low d high. So low is x squared plus 1, the denominator. D high means the derivative of the numerator, which is just a 1, which you did not really need to write. Low d high less high, the numerator, and then d low, the derivative of the denominator, which we do term by term. The derivative of x squared is 2x, and the derivative of a constant is 0. So that's it. This is a full credit answer. I am just going to simplify this a tiny bit. Taking away the little 1, we just have the x squared plus 1. Multiplying these together, we have negative 2x squared. And then we notice that these are like terms. X squared minus 2x squared is negative x squared. This is the simplified derivative. Resist the temptation to cancel out one of the x squared plus 1's from the denominator with this x squared plus 1. The reason why is this is not really x squared plus 1. We would need parentheses in here, which we do not have. So, yeah, you cannot cancel out the x squared plus 1. So, we're done. I'm going to do number 6 two different ways, because I probably wouldn't actually do the product rule on this one. I would probably just distribute. But either way, understand that the square root of t is equivalent to t to the 1/2 power. So we have this. So first I'm going to do this using the distributive property. So h of t equals t to the 1/2 power times 1 is t to the 1/2 power. When you multiply the t to the 1/2 power times t squared, you add the exponents. So in my mind, I'm thinking 1/2 plus, and then 2 is the same as 4 halves. So 1/2 plus 4 halves, that's 5 halves. So this is going to be minus t to the 5 halves power. Now we can take the derivative term by term very easily. For the first term, we move the 1/2 to the front, and we reduce the exponent by 1. 1/2 minus 1 is negative 1/2. And then here, I'm going to again move that exponent to the front, so we have minus 5 halves t. And reducing this by 1. So in my mind, I'm thinking minus 2 over 2. So that will be 3 halves. Or we can think of this as a product rule situation. So the first time through, we take the derivative of the first factor. So we'll have I forgot to write my prime here. H prime is equal to that. That's the answer. So h prime of t equals, and using the power rule, put the 1/2 in the front, t to the negative 1/2 power. I'm going to need a little bit more space. The first time through, we leave the second factor unchanged. So that would be 1 minus t squared, and then we put a plus. The second time through, we leave the first factor alone. So we leave our t to the 1/2 power, and we multiply by the derivative of the second factor. The derivative of 1 is 0. So moving on to the negative t squared. Do not leave out the negative. The power rule tells us to move this 2 kind of to the front. So we have negative 2t. So this is another full credit answer. This answer and this answer are equivalent. I don't think I'm going to bother. I guess I feel like I have to show that they are equivalent. So, if this were a test and you did the product rule and this is a free response question, you would just stop here. You wouldn't simplify anything at all. If this was a multiple choice question, the answer is not going to look like this. So you would distribute this monomial in front of the 1 minus t squared. So we have h prime of t equals, obviously this times 1 is just 1/2 t to the negative 1/2 power. When we multiply times the second term, we'll have minus 1/2. When you multiply with like bases, you add the exponents. So the question is, what is 2 minus 1/2? All right, I'm adding these together. Well, this is the same as 4 over 2 minus 1/2. So that's 3 over 2. So we have t to the 3/2 power. And then over here, I'm going to go ahead and put this minus in the front. The minus 2 will be here. And now we're multiplying these together. This t is t to the 1 power, which is like 2 over 2. So 2 over 2 plus 1 over 2 is, whoops, I forgot the t. So t to the 3 over 2 power. Now these two are like terms. So see how this only has 2 terms to it? The first term matches. So it's just a matter of combining these like terms. So the question is, what is 1/2? Well, I guess negative 1/2 minus 2. Well, 2 is 4/2. So yes, that is negative 5/2. As you can see, it was more efficient to do it the first way. Number 7, another quotient rule problem. Let me not forget the prime this time. So quotient rule. At the end, the bottom squared will go. So I'm just going to knock that out first. Bottom squared will go. And I'm looking at this square root of x as x to the 1/2 power. In the numerator, the quotient rule goes low d high, less high d low. Maybe I'll just go ahead and put the minus sign right here. So low is the x to the 3rd power plus 1. D high is the derivative of the numerator, which is going to be 1/2 x to the negative 1/2 power. That was our power rule. Less high d low. High is just the numerator, x to the 1/2 power. D low is the derivative of the denominator. The derivative of x to the 3rd power is 3x squared. And the derivative of 1 is 0. So that's the answer. And we could leave the answer like this. The only thing I would probably do, if I were to simplify at all, would be to multiply the x to the 1/2 power and the x squared, adding those exponents. So here's a slightly simplified version of the answer, but if this was a test, please leave your answer like this. For number 8, we will need the product rule. We have the yellow factor times the blue factor. We are going to find the derivative by taking turns with that derivative. The derivative of the yellow function is 3x squared. And the first time through, we leave the blue function alone. And we put a plus. Second time through, we leave the yellow function alone. And we multiply by the derivative of the blue function. The derivative of cosine is negative sine x. Do not put the negative right here. Instead, put it in the front so you don't accidentally turn it into a subtraction problem. Okay, the minus goes here. And really just stop there. There's your answer. I encourage you to do the quotient rule for number 9. When I see the x in the numerator and the denominator, I'm going to do the quotient rule. So, blah, 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 the bottom squared will go. So I know I'm going to have x to the 4th power in the denominator because I'm squaring the bottom. In the numerator, it goes low d high, less high d low. So low is your x squared. D high, the derivative of sine x, is cosine x. Less is subtraction. And then it's high d low. So sine x times the derivative of x squared, which is 2x. Resist the temptation of canceling out any of these x's unless, I would leave the answer like this if this was a test. But we do have a common factor here. See, there's x's in both terms, so you could do this. G prime of x equals, you could bring out the common factor of x. That's going to leave behind x cosine x minus, I'm going to put the 2 in the front, 2 sine x all over x to the 4th power. Now that I've turned it into multiplication, I can cancel out one of these x's. So if this was a multiple choice question, the answer would likely look like this. X cosine x minus 2 sine x over x to the 3rd power. Kabam! Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.